Next, we want to set up the logic that will destroy the apples that collide with our basket pawn. So I will navigate to the basket base header, and I will declare an onHit function that we will bind to an event later on. The function has quite a number of formal parameters. It needs to be compatible with the onComponent hit event. The formal parameters will include a pointer to a uPrimitive component, which I will call hitComp for hit component, and the second parameter here is a pointer to an A actor that is going to be for the other actor. Of course, other actor will be the apple that collided with the basket. Next, we have a pointer to a uPrimitive component for the other component. Next, we will have an F vector for the normal impulse. Finally, we will have a reference to an fHit result constant, which I will name a hit. We need to decorate our onHit member function with the uFunction macro, since we want to bind this to an event or delegate later on. Well, we can set up the binding in the constructor, and you can go ahead and try that if you want. Sometimes the binding does not register when you set it up in the constructor, so I prefer to do that in the begin play. I'll use the addDynamic helper for calling addDynamic on delegates. Delegates can call member functions on C++ objects and can be bound to a member function of an arbitrary object, calling the function on the object at a future time. We are not concerned with creating custom delegates at this point. We want to learn how to use existing delegates first. Setting up custom delegates is a bit more complicated, so for now we want to use what we have available. This onComponent hit is a delegate or an event, so onComponent hit. When that event fires, then we want to call this onHit function, our custom onHit function. If you pick definition, this is an event called when a component hits or is hit by something solid. That is something that has collision. This could occur as a result of character movement, set location with sweep enabled, or physics simulation. For events when objects overlap, you have overlapped events for that. So for example, when a character walks into a trigger, that is an overlap event. That is not what we really want for this. We want the onHit. We have events for that, such as onBegin overlap or onEnd overlap. An important note here is, for collisions during physics simulation, to generate hit events, the option simulation that generates hit events must be enabled for the component. I will pick definition on addDynamic. This is a helper for the binding, and it allows us to specify only 2 arguments instead of a more complex argument list. It is going to generate a function name string for us. You can include the primitive component.h file, since that is where the onComponent hit event and some of the other events are declared. That is in the case we have compilation issues, but it works for me without this include, so I will comment that out. Next, we want to do a cast. This will allow us to check, so is the other actor of type AppleBase, and if so, it will return a pointer to that. I want to reference that class AppleBase, so I will include that at the top of the file. When the other actor, the apple, collides with the basket, then that actor will be of type AppleBase. In this way, if an instance of some other class collides with our basket, maybe some visual stuff that I have spawned, then those won't get destroyed, and ultimately those will not affect our game score counters. With the destroy function, we will destroy the other actor indirectly, as you can see here, using a pointer, which will be the apple. Back in the editor, if you hit play, it may just collide again without destroying the apples. So I will open the basket blueprint. I mentioned this earlier. Simulation generates hit events. We need to check that. If I compile and save, go back and play this and try this again. The hit events are now generated when the apple collides with our paddle, and that will fire off our onHit function, which will then destroy that apple. One final demonstration before we end off this particular lecture. In the content browser, I will search for floor. I'll just go and dock this actually. Then we need to check show engine content. And then if I search for floor again here, notice that we have a floor underscore mesh. I will drag that into the scene and I will position that. That does have some collision, so if I play this, those apples will collide with the floor. Next, I will make sure to turn off that show engine content setting, and I will navigate to the blueprints, the Apple blueprint, and open that up. Then I will search for and navigate to the collision section. By default, the collision preset is set to block all dynamic. We can change that so that we can ignore the world static. The floor is set to static, so if I go ahead and play this, those apples will simply fall through that floor. And if I set the floor to movable, for example, and I play again, then the apples will collide with the floor. Set it back to static again, and now those apples will fall through the floor again. Or set the collision preset back to the default, which is block all dynamic. Compile and save that. I just wanted to demonstrate this again as a recap, that you do have those options available to you just in case you want to do something. Maybe you want to set up some additional pedals or rotating pedals and stuff like that. You can set them up. That is to confuse the player. Maybe not in the first level, but maybe in some of the upcoming levels. The apples will fall from the tree onto some pedal, and maybe that can delay the falling of that apple, and the player will have to go back to catch that apple. So again, I just wanted to recap the collision presets.